Okay, so here's your video that should have been posted last night. 5-2, solving quadratics by graphing. You've got three possibilities when we graph parabolas. So you've seen a few, but if we're going to solve it when y equals 0 for the ax squared plus bx plus 3, we've got three possible solutions. We can have obviously an up or down parabola, but the possibilities are that the parabola will intersect twice on the x-axis. So whether it's up or down, it intersects twice. So here's a down parabola intersecting twice. Here's an up parabola intersecting twice. We could have one single solution. So the parabola, whether it's facing up or down, rests at its vertex on the x-axis. And we could have the parabola not resting on the x-axis, not intersecting the x-axis at all. So therefore, it would be no solution. So those are our three possibilities: 2, 1, and no solution. What you're going to do is you're going to graph. You're going to look for those intersections of the parabola and the x-axis. Of course, you can get non-integer solutions, so you won't get a nice round 1, a round 5, a round 6, a -2. When you have those, you were going to tell me, you're going to state your answers as, oh, x is between these two integers. So like this would be x is between -2, -1. This is between 2 and 3. So those are the nearest integers. So here's how those are stated. X is between -2 and 1, x is between 2 and 3. When the value of the function is positive for one value and negative for the second value, then there is at least one zero between those two values. So here's what it's saying. So you can see this visually. Our y is, you can see that the y values are decreasing, and let's go through this. So here's your f of x. So you see 0 and 1. So you can see between 0 and 1 that there is a 0 or an x value. And on the table, you can see the change in the y values, that you go from positive to negative. You can see this graphically. We're decreasing, and it goes from a positive y value to now a negative y value. The same thing on this side of the graph. Now that it is rising from the vertex, we have negative y values, we've got positive y values. And that happens here in the table between the 5 and the 6. You have a -1 and you have a 4. So the x-intercepts of the graph indicate that one solution is between 0 and 1, and the other solution is between 5 and 6. We have word problems. Find two real numbers whose sum is 15 and the product is 63, and show that no real solution exists. So when we have this sum of 15, we've got one number x. If they both add up to 15, then this number adds up, and then we can take the x from 15. Then these are our sum of 15. Our product is 63, so they're going to multiply up. Here's these two numbers multiplying up to 63. If you will perform FOIL, you've got 15x. You've got this negative x squared. This equals to 63. And then here is your quadratic equation, moving your 63 over. And then if we graph this, then you can see that this is going to not intersect at the x-axis at all. And then we have another word problem that we can do together as you guys take your notes here in class, because it wasn't posted last night.